Good morning, and thank you for joining us for another Webinar Wednesday. Today we're going to be covering an introduction to SOLIDWORKS CAM presented by Chris Watkinson from CAD MicroSolutions and Rob Manwell from our CAM partner, CAMS. Please keep in mind that we will save some time at the end of the webinar for a question and answer period with both Chris and Rob, so feel free to type in your questions into the question section of the GoToWebinar panel at the right-hand side of your screen. We'll do our best to get to all of the questions at the end of the webinar, and if we run out of time, we'll be sure to follow up with you afterwards. So without further ado, I will pass things over to Chris to get us started.
Thanks, Jessica. Hello, everybody. We're going to take about an hour to go through the basics of a new product that's been added to the SOLIDWORKS product line in SOLIDWORKS 2018, SOLIDWORKS CAM. I'm going to kind of talk very briefly about how SOLIDWORKS CAM fits into the overall strategy of CAD MicroSolutions and Dassault systems, what the product is, what its capabilities and packaging are, the typical critical business issues and return on investment that customers can enjoy, and then Rob is going to do a SOLIDWORKS CAM and CAMWorks demo, and then we'll discuss if you're interested in actually implementing it now that it's included in your SOLIDWORKS portfolio, how would you go about doing that? So this is a bit of a busy infographic, and the reason why it's busy is there's a lot that's happening in design and manufacturing. We're on the eve of a new era, and we're in the middle of a new industrial revolution that a lot of people are calling Industry 4.0, whether it's 4.0 or 5.0 or whatever isn't the point. The point is that the CAD model, the digital twin, is the center of unleashing value to the experience of an economy. And there's a whole host of different technologies that are amplifying one another at the same time. These include augmented reality and virtual reality, inexpensive robotics, smart robotics, cloud computing, big data, digital manufacturing, and many others. When we talk about the design process and the value proposition of SOLIDWORKS and their products, traditionally it was just CAD and simulation and PDM, the engineering 3.0 tools that we talked about at our last SOLIDWORKS launch event. But SOLIDWORKS and Dassault systems are fulfilling the promise to enable innovation by really adding a lot of products over the past couple of years in many different areas, and also fulfilling the promise for the SOLIDWORKS subscription customer by adding new modules to your existing product every year. At SOLIDWORKS World 2017, they made the announcement that they were going to be including CAM capability in the form of SOLIDWORKS CAM in every license of SOLIDWORKS. We have the same sort of commitment and are aligned with Dassault systems with our customers that we need to enable you to unleash your CAD data for providing value to your customers. And we have a comprehensive digital manufacturing strategy. It's both additive manufacturing, 3D printing, and traditional subtractive manufacturing, CNC machining, and fabrication. We've been involved with, as a CAMWorks partner since 2001. Some of our largest customers have CAMWorks. We think that it's a natural, if you're going to spend the energy to create a 3D model, why use it to only create 2D drawings? Why wouldn't you use it for downstream applications in manufacturing? If you're on the webinar today and you happen to be a case goods, cabinetry, furniture manufacturer, we also carry another CAM product called SWOOD, which is very useful for wood, metal, glass, and case goods. The SOLIDWORKS CAM product is also kind of dovetails with our technical communication strategy for model-based definition, and essentially that's the ability to put all the GD&T and embed it within the 3D CAD model, also using that for quality control, CMM inspection, and work instructions. And we also have a comprehensive digital production strategy, which you're going to be hearing a lot about in the future. If you would like to enable your production environment with IoT, we'll be having webinars soon to talk more about that. So that you can see how The manufacturing world is changing a lot, and a lot of these applications are becoming disruptive because they're becoming so commonplace and so affordable. So what is SOLIDWORKS CAM? So let me go back here for a sec. So SOLIDWORKS CAM, powered by CamWorks, it's first of all, it was one of the first gold partners for SOLIDWORKS, meaning that it's fully integrated into the SOLIDWORKS user interface. It shows up as another tab. It has 2.5-axis milling and 2-axis lathe programming capabilities. And it leverages the solid model to automatically recognize machinable features. Once it recognizes those features, it looks at a technology database and is able to look up in the database what machining strategy is most appropriate based on that geometry. And then it can generate a toolpath and produce G-code that you can input into your CNC machine. It's fully associative with the SOLIDWORKS model, meaning if the geometry changes, that the toolpath updates automatically. It is synchronized, obviously, to every release of SOLIDWORKS. All of the machining data that you create is embedded in your SOLIDWORKS part and assembly files. What is CamWorks? So CamWorks was first released in 1997. It was one of the first gold partners for SOLIDWORKS. Every single SOLIDWORKS demo that we did back then included a preview of CamWorks and CosmosWorks at the time, which became SOLIDWORKS Simulation. So very similar to SOLIDWORKS taking on CosmosWorks, SOLIDWORKS has now taken on CamWorks and integrated into the product line. CamWorks has a full range of machining capabilities, all the way from 2-axis machining all the way up to 5-axis and high speed and wire EDM and nesting. SOLIDWORKS CAM is a subset of that SOLIDWORKS or that CamWorks capability. Essentially, it has two different packages: SOLIDWORKS CAM Standard, which is included in every license of SOLIDWORKS on subscription, and it has 2.5-axis machining on parts and tolerance-based machining. There's another upgrade available, which costs $2,400 US for the license and $600 for subscription, which extends the capabilities in SOLIDWORKS CAM to add the ability to leverage SOLIDWORKS configurations, to machine in assembly mode, to have high-speed machining, but also to do 3-axis machining and 4th and 5th axis positioning. What are the typical critical business issues that SOLIDWORKS CAM addresses? Well, I think I'm not going to go into too much detail on these because I think you're going to see them very eloquently during Rob's demo. But essentially, why, if we're very good at recognizing machinable features inside of the CAD environment and generating operations plans and automating the generation of CNC programs in a very professional and robust way, and then we're able to validate those toolpaths graphically and post out accurate information, why wouldn't you do that? Why would you want to have to start over every single time that there's a change in the CAD geometry? Change and revisions are becoming it's just a part of doing business, and with the pace of business increasing all of the time, that revision cadence is shortening all the time, and so companies do need the ability to react much faster. And if you have to start from scratch every time that there's a change in the geometry, or really very carefully, meticulously validate that your CNC programs are going to be correct to that revision, then that's just going to slow you down. So SOLIDWORKS CAM is a natural way to efficiently, automatically generate toolpaths that are professional level quality toolpaths, validate them, and load them into the machine. And people really enjoy quite a high return on investment when they implement SOLIDWORKS CAM. Typical return on investments are reduction in programming time of 20 to 50%, reduced cycle time on the machine. If the the more metal chips that you're cutting, the bigger return on investment you're getting on that CNC machine. So using our high-speed machining routines, we've been able to show that customers enjoy a 40 to 75% reduction in cycle time and a much easier file management. Why have all of these different machining files all over the place? It's much better to embed them in the digital twin. And again, if there's any changes to the geometry, we automatically update the toolpath. And SolidWorks CAM and CamWorks are excellent at NC verification and the prevention of crashes. So what's the return on investment by having confidence in your toolpath and preventing crashes? I mean, that's priceless. One crash could literally cost thousands of dollars in tooling and machine repair time. Some CamWorks customers, again, CAD MicroSolutions has been in the CAM market since 2001. Some of our two largest customers are heavy users of CamWorks and SolidWorks CAM. Many of you that came to our launch events will remember Ryan Wozniak from Anchor Danley talking about CamWorks and SolidWorks CAM. And he also talked about his experience as a CAD MicroSolutions CAM customer and how much value he sees in our partnership with CAMS. CAMS is our CAM partner. They provide our CamWorks and SolidWorks CAM training and advanced technical support and post-processor implementation. They're headquartered out of Columbus, Ohio. I just checked this morning to see when the first conversations with them started and when we first started sharing customers, and that was just about 10 years ago. So it's been a long, productive relationship for both customers, and both customers and CAD MicroSolutions and CAMS. They've been involved with CamWorks since 1997, since day one, as an authorized CamWorks reseller. So let's turn it over to CAMS and Rob and have a look at the product.
And you should see a screen that says SolidWorks 2018 on it. All right, fantastic. Hi, real quick, guys. My name's Rob Manwell. I have to apologize. I think Jessica and Chris might be my interpreters. You may detect I'm a little farther south from the way I speak. I'll try to slow down. I get really excited about CAM and SolidWorks. I've been using SolidWorks and CAM since the late 90s as well. And my intention is to show you basically the functionality of how SolidWorks CAM works, but also some of the other things that you have to look forward to. Jessica, if you're there, can you see my screen? Still look good?
Yep, still looks good, Rob. We can see you.
Fantastic, thank you. Okay, so the first thing you'll do is you'll notice that for those of you that are used or accustomed to SolidWorks, there's an add-ins option, and on your add-ins, if you don't see SolidWorks CAM available, this is where you'll find it at. So you can turn it on immediately, or you can put it in your startup so it turns on every time that you open up SolidWorks. You'll also notice that over in your browser on the right-hand side, you can go through and you can define different areas. And there is an examples directory that you can get some idea of how part programs are made in SolidWorks CAM. In this case here, I'm actually going to be using a directory that I set up for myself just to cover some of the functionality that's inside here. So I will not be covering any design elements inside of SolidWorks, but that is something obviously that Chris can help you out with if for some reason someone needs some assistance with that. This part I had already designed in SolidWorks, and I'd like to tell you it has lots of functionality, but the truth is it's kind of a widget. It's just something that I wanted just to be able to show the basic functions inside of SolidWorks CAM Standard, which everyone has as long as they're on subscription. What CAM Standard does for you is it gives you the availability to machine an individual part model. And one of the things that you'll notice is when you first turn on SolidWorks CAM, it just adds some functionality over here to your feature browser. So on the left-hand side, you've got your standard SolidWorks features in your design tree. You also have a CamWorks feature tree, a CamWorks this is bi-directional. This can be CamWorks or SOLIDWORKS CAM. If I say both, I apologize for that. I show both. So SOLIDWORKS CAM operations tree and the SOLIDWORKS CAM tool tree. When you start creating a program inside of SOLIDWORKS CAM, the first thing that you would do is you would look to address what kind of machine tool it is. This can be modified right inside of your feature browser or your feature tree, or you can also do it from your ribbon toolbar up the top that we're all accustomed to for using for features and sketches and things of that nature as well. There's just simply a SOLIDWORKS CAM ribbon bar that's added into your top pull-down list. From here, I'm just going to right-click and edit this definition. And you'll notice that inside of SOLIDWORKS CAM, you have a milling environment for milling machines. You also have turning machines as well. If this were CamWorks, this would add in functionality for mill turn machines, and you would have 5-axis simultaneous, 4-axis simultaneous type capabilities at this point. The next tab over, this simply goes and shows you what type of tools that are available currently in the tool crib that I'm using. This tool crib could also be a turret on the machine for dedicated tooling, so that if you're only running specific tools on that machine, this would be listed inside of this crib. There's also a tool library where you can go and you can identify any type of tool that you want to pull from a library. So this might be something where the company, your entire company database of tools would exist. Next would be the post processor. This truly is the most important part of CAM. This is basically your printer driver. To probably put it into perspective, if you have an HP printer and you try to run a Brother printer driver on it, it will not run. So ultimately, this is the most important portion of your system. It's all pretty graphics on the screen if you don't have a proper post processor. And another term that's used for this is code generator as well. And if you scroll down through your list, it just shows you the available machines that I currently have inside here. And we'll go ahead and just pull up this Haas VF3. And we'll select that to add it up into our active post processors. Posting information. There's not a lot of posting information that's output inside of the standard post processors. If for some reason you end up with one of our post processors that we create at CAMS, there's a lot of additional functionality that's put in this. So that is something that if for some reason you're using the standard post processors and you need additional functionality, you can talk to Chris and he'd be more than happy to get us information. We can work to help you out on that. From here, setup information. I can define the setup information here, but typical of SOLIDWORKS, I can define it other places as well. I'm going to show you a different place to define that information. Rotary axis and tilt axis. This is more indicative of the CamWorks environment or the SOLIDWORKS CAM professional environment, and I'll try to show that at the end if we have enough time to do it. So, Jessica, can you still hear me okay?
Yep, Rob, loud and clear.
Fantastic. It gets kind of quiet and I get lonely out here in Arkansas, so I just like to make sure that people are still with me. So from here, I've defined my machine. The next thing I'd like to look at is the actual stock on my part, because ultimately we have to have something to machine from. And you can see it just adds a iridescent or a translucent box around my part. And there's several different stock types that we can create. We can do it from a bounding box. We can use an extruded sketch, so a SOLIDWORKS sketch. We can use an STL file, also known as a stereolithography file. This is very common in castings and forgings and things of this nature. Or we can use another part file. This can be a file that you've created inside of SOLIDWORKS, or it can be a dumb model from somewhere else that you saved down just to be able to machine from. Here you can add stock and take away stock, so it's very quick and easy to go and add stock in any direction that you want. And at this point, I'm just going to leave this stock around this part right where it is. I'm going to say OK. And here I'm going to set up my coordinate information. Now, this is the same thing that I was explaining about earlier when I mentioned that you could do it in several different places. And there's several different options I can use. I can use a user-defined system, which I'm going to use on this particular part, or I can also use a SOLIDWORKS coordinate system. So if you're very comfortable creating SOLIDWORKS coordinate systems, virtually you can create any coordinate system that you want and leverage that at any place inside of SOLIDWORKS CAM as well. You can choose a part bounding box, and you can see there's nodes at the top that you can pick on. Or you can use a stock bounding box. If the stock is bigger than the part, you can pick on those nodes as well. I'm going to pick this upper left-hand corner up here because typically this is where you would have your solid jaw on a vise at the back of your part, and I'm going to accept that. And you'll notice this updates. Before I had a little icon up here alerting me that this had not been defined yet, and now that has gone away. I probably should have pointed that out. I apologize for not doing that. From here, define machine, set up my stock, set my coordinate system. I've done all of that information. I'm just going to extract the machinable features on this geometry or on this part model. And what it does is it comes up and it automatically adds my setup in here. Now, if this part had additional features in SOLIDWORKS CAM Pro, it would have also set up multiple mill part setups on each side of this part, whether it be on the top of the part or whether it be on the, one of the faces of the part. In this case, you'll also notice that the features are blue. This is a very common functionality inside of SOLIDWORKS because obviously if a sketch is underdefined, it is blue. When it's fully defined, it turns black. So what this is telling me is these features currently have nothing being leveraged to be able to program them. So I need to generate my operations plan, and I'm just literally working my way across my ribbon toolbar here. I generate my operation plan, and you'll notice I have a blue face feature, but these have now turned black, meaning they're fully defined. Very common, functionality that we're accustomed to in SOLIDWORKS. It switches me to my operation tree, and you'll notice in my operation tree, these are underdefined. So even though my operations have been created, I haven't generated my toolpath yet. Once I generate my toolpath, it automatically changes everything to fully defined, which is now black. And I can simply walk down through here and I can see the features that are created and the machining that has been created on it. Now, with feature-based recognition, there are a lot of things that you get that you may or may not need. So for example, right now, this is machining out this pocket area here all the way around my part with this tool. However, if I move down, I also can machine this individually, and I can finish it individually. So there's additional toolpaths in here that I could use. It doesn't mean that I have to use them. So in this case, I really rather just run this toolpath all the way around the part. So I'm going to take this toolpath down to this toolpath, and I'm going to suppress them. So once again, very common term in SOLIDWORKS, same thing in SOLIDWORKS CAM. Not only can you suppress features in SOLIDWORKS, you can suppress toolpaths inside of your CAM system. This is very important because you may want to come back later on and leverage those toolpaths. So it's very quick and simple to be able to do this. I also noticed that my rough toolpath up here looks kind of small. So there's a couple different ways I can change this. Now I can right click on this and edit this toolpath. And you should see a dialog box up here with a tool in it now that I can rotate, and I can zoom, and I can pan, and I can turn it on and off, and all kinds of different things in here. I can change my information here. This would be like in regards to the tool. I can also go to my tool crib, and I can make changes here and say, you know, really I want to use a bigger tool on this, and I'm going to go ahead and select that tool. It also comes up and it says this tool has a holder that corresponds with it. Do you want to bring that holder over as well? So it's intelligent enough to know, hey, he's changing this tool, let's bring the holder for it as well. And I'm going to say, yes, I do want to bring that holder over. Shows me my holder information, my tooling information, my stage, my tool number. It also shows me the operations that are currently assigned to this tool. I can change feeds and speeds. Now, currently, I've got it set up to where it's actually driven off of the material library. So if you're using a specific material, it will pull that information from the material library instead. If I wanted to, I could change that to just the individual operation or just to the tool and give it whatever information I want from there. Strategies that I want to use, whether I be pocket in, pocket out, zig or zigzag. Chris mentioned high-speed machining. That's a tool path called volume mill, and I'm actually going to show that on a different part. NC information. This is your typical machinist thought process here. You know, where's the rapid plane to the top of your part? Where's your clearance plane? You know, how far down do you want to get down there before you move from one piece of geometry to the other? Additional options. Sometimes, even though a piece of geometry is designed to a certain depth, you may want to add additional depth to it, or you may want to override some of the depth. There is functionality in here to be able to do that as well. For most of us programmers, we're kind of control freaks when it comes to toolpath. We want to make sure that we can do exactly what we want. So because of time, I'm not going to be able to go through every one of these, but I'll go ahead and I'll accept that. And you'll notice that my toolpath has changed. It's now using this 3/4 inch end mill, and it's cutting a much bigger depths of cut because it knows that it's capable of doing that because of that tool. Now, that said, if I go to my tool tree, this is my 3/4 inch end mill. You'll notice I've got blue tools and I have black tools. These tools are underdefined, the blue ones. There's nothing there available for it to actually be able to see. It's not programmed using any of those tools. They're available in my tool crib, but I'm not using them. Inside of here, you'll see that I do have tool paths underneath my 3/4 inch tool. 2 of them are suppressed. I also have one underneath my 1/4 inch tool. Well, I always thought, wouldn't it be cool if I just wanted to take this contour and move it down with this tool? That would be awesome. And luckily, you can. This would be very similar to a child-parent relationship. If it's available to do it, and you can drag and drop it. You can move it anywhere you want to inside of this so that it runs now with this 3/4 inch tool. Back at my operation, I now have my rough mill with the 3/4 tool, and I have my contour mill with the 3/4 inch tool. From here, I have my tool paths kind of how I think I want to see them. At this point, you could either do one of two things. You could generate the tool path or you could simulate it. Well, I kind of like to see a simulation first. So this is just going to be that one individual tool path showing the simulation. Jessica, if you could, let me know how this runs.
Yeah, it's really updating really smoothly. Sorry, this is Chris, not Jessica, obviously.
That's okay. I almost said, Jessica, you have a beautiful voice. It's fantastic. So inside of here, you can rotate, zoom, pan as well. You can speed up the cut. You can slow down the cut. You can rapid tool pass. So if we want to see this thing go a little bit faster, because I'm going to show some much nicer simulation here in a little while. You can see the tool. You can also go in and you can say, show me the difference between the machined part and the actual model. and it will tell you what tolerance band it's within. And right here, I've got this light blue to green is within 0 tolerance. So I've got this machined right to tolerance. If it were in this dark burgundy red or almost blood red color, you know, that would be under tolerance. And if it had blue, it would be over tolerance. So that's something else to be aware of. It kind of keeps you from making mistakes and not quite getting the tool path that you need. There are obviously offsets and things that can be done inside of here. And if there is an offset, it will show you you're leaving material on that part. Now, so this is at the point where I would want to generate code. This is really where everything, you know, the rubber hits the road kind of thing. And at this point, I'm going to click Post Process. And it's going to ask me what type I want to code. So for example, if your machine control only takes an NC extension, you choose that extension. And you can give it a number up here, or it will automatically take the name of the part that is programmed. So I'm going to hit Save. There are a few options down here, and I'm going to tell it to open my G-code editor once I've hit play on this thing. So once I come in and I close this out, it will automatically open up my code for me. And from here, you'll notice this is also colored. So standard moves, standard tool call-ups are in black. Rapid moves, where the machine is in rapid mode, is in red. When you're in feed moves and linear feed moves, it's in green. And when you're in circular moves, it's in blue. So it kind of gives you a good idea as you're walking down through here, kind of what things look like. And you can even backplot in this system as well. So I'm not going to cover a bunch of the editor stuff, but this is something functionality-wise for the machinist on the floor that actually want to simulate real-time G-code. The editor that comes with the system will do that also. So let's just get rid of this, and we'll go on to something new. All right. Inside of SOLIDWORKS CAM Professional, you can do turning as well. So if I was going to do it's funny when I first taught my first SOLIDWORKS class, and you were talking about, you know, the turn method versus the milling method versus the revolve versus the stacking things up. You know, it seems real simple when you first start talking about it, and then you realize how easily you can make a part out of literally 2 features, a revolve and a chamfer. And there's a lot of geometry on this part for a 2-feature part. So when I first looked at it, I thought, wow, that's cool where we've come from the 2D world. From here, once again, I'm going straight over into my part. I'm going to configure my machine, and I'm going to move things a little faster here. So I'm going to select this single turn machine down here. This is my dedicated tooling or my tool crib that's available for me, my post processor, and I'll just grab this ST20 down here. That's a very common machine. Posting, setup information, I'm really not worried about now. If I have a main spindle and a sub spindle in CamWorks, that's a little different ball game where you're adding, you know, multiple spindles in on a machine. But one of the cool things that I like is the fact that I can go in and define my chuck right inside of turning. So the chuck is much easier to define than what a mill type machine would be like. And I'm going to show you how to do that as well. But just real quick, just nice to be able to go in there and that fast have that chuck in the machine. So stock, same type of system, you know, as far as, you know, round bar stock, a revolve sketch. I can do a work in process. So if I previously machined this on another machine, I can use that. STL file and a part model again. I can add stock to the OD, the ID, and the face. The chuck automatically updates off of what I changed that stock to. And then also things like, is it a solid part or is it a cord part? I'm going to leave this as solid, but if this were, say, like a tubing, you would want to use a cord part because it already has the hole on the inside of it. So we'll go ahead and say okay to that. And once again, it's very similar to everything inside of SOLIDWORKS CAM. It doesn't change significantly from the milling environment. It's just simply a turn part. From here, I'm going to extract the machinable features. It automatically adds my turn setup in. I have a face feature. I have an OD feature. Let me zoom this up a little bit here. OD feature. I have a groove feature. I actually have two groove features, and I have a cutoff move. From here, I'm going to generate my operations plan. You will notice that this is not blue over here. I have this set up a little bit differently on this part. It's done up as a magenta colored. This can be changed to whatever you want it to be if you prefer it to be blue. I'm going to generate my tool path. And now you'll see I have a face rough, a face finish. I have a rough turn, a finish turn. I have a groove, finish groove, rough groove, and a finish. Now, this also can be drag and drop anywhere I want, not just the tools. I can also move tool paths around. So if I'm going to rough both these first, then finish them, I can do that as well. Have my cutoff move. Usually it is at the last. That's usually the smart place to have it because otherwise it falls into your machine in the middle of things if it's not there. So buyer beware, make sure your cutoff moves are generally at the last. That's just where they tend to go. Unless you're on a sub-spindle machine, sub-spindle machines can come in and pick up off like an OD on the face of the part, do a cutoff move, and then do back work on the back side. And CamWorks has the capabilities of doing that as well. The last time I went up and I picked simulate from up here on my ribbon bar, but I will point out that you can also add CamWorks or SOLIDWORKS CAM commands into your mouse gestures. So from here, I have simulate right over here to my left-hand side. If I sweep across it, it automatically puts it into simulation mode. I used to fondly call that the wheel of death until I realized what an awesome tool it is. And saw a young man design a part faster than I could probably think about designing it using mouse gestures. So something to be aware of if you're not using them. It's a very capable tool that is inside of SOLIDWORKS. From here, I'm going to hit play, and that's your turn part. This is all part of SOLIDWORKS CAM Professional. I'm going to close that out. And I'm going to speed up a little bit more. So next part up is going to be, this is kind of interesting, Chris. I noticed that you had a Kurt Weiss on one of your screens, and it just so happens, I think I've got the same Weiss, or if it's not, it's really close. So good minds think alike.
Cool.
This is going to be a little bit different. So now we're starting into what's called assembly mode. Assembly mode is in SOLIDWORKS CAM Pro. So the cool thing is in assembly mode is not only am I looking at all my fixturing, but I can also do multiple parts. And so in this instance, I'm going to go through, I'm going to program this part quickly. Then we're going to look at a more in-depth part. So quickly, I want to go in and I want to add this part in. If I had more parts, I can add those in all at one time. And it says, okay, now he's working on this part. I know what he's trying to do. I'm going to set my coordinate system. And on my coordinate system, notice it knows a lot of different things about what's going on in this part right now. So I can go in and I can say, I want to do a part bounding box. I can actually pick up coordinates off of my fixturing, or I can go in and I can pick up coordinates off of my part. In this case, I want to use my part, but this could be if you had, say, like a tooling ball pickup on a fixture, that would be a very proper way of using the fixturing instead. So we start to add a lot of functionality in here when it starts coming into being able to work at an assembly level. From here, I'm just going to extract the machinable features. And because I added that part model in, it knows that it's only working with this part. I'm going to generate my operation plan and generate my toolpath. Now, if I go into simulation from here, you're going to see a part. That's not ultimately what I want to see. I want to see this fixture in here as well. So when you're doing something of that nature, it really needs to be able to be done at a setup level, because fixturing can change. You might have one part of the program and one configuration in SolidWorks running one way, but want to have it a completely different way when you start to run the second portion of the program. So SolidWorks CAM allows you to go in and add fixturing, turn it on and off anytime you want. You can also choose to avoid it. You can do it in a simplified means, or you can do it in an exact means. The only difference you're seeing here is going to be calculation time, because exact looks at every single aspect of that fixturing. Now when you simulate, I have my fixture. Do I have a fixture, guys?
Yeah, you have a fixture.
Okay, I just wanted to make sure. I like to test every now and then and see if people are watching me. So, and I'm going to hit play, and we'll just run through that toolpath real quick. Now this does do avoidance as well. If I were to wrap it into this part with either my tool, the shank of the tool, or the tool holder, I can also tell it to stop at collision, ignore, cut. So these are other options available to keep you from colliding into your part, the tool shank and the tool holder. So that's an assembly part in a vise. And when I assembled that part in there, I just used typical mates. You know, in the assembly, it is no different than anything that you currently do today. So if this is assembled in engineering, or if this is assembled in manufacturing, it doesn't matter. All right, let's close that one out. Last but not least, I always think it's kind of nice to end with something just kind of cool. And I've got a large tombstone part with multiple vices on it. And it was always interesting to me as a subscription customer, because I've been in the manufacturing and engineering industry for a long time. I kind of always wanted to know where my money was going. And I think ultimately SolidWorks, by coming up with a CAM option on subscription, really did the right thing. For any of you that have run through any of the Express tools, they're fantastic. But for SolidWorks CAM to basically be an Express type item, the functionality is extremely capable, especially for milling machines, and for not much money at all, to be able to add in multiplane indexing and turning. It literally covers most customers' needs. There is the occasion where someone else needs additional, but to be able to be in at literally $3,000 with subscription, to be able to have this type of functionality. This is a rotary table. It's on a B-axis horizontal machine. It has multiple setups. So not only just one setup, it's doing multiple setups on multiple parts. These are the part instances. This has indexing on it. One thing the reason I'm using this part is, number one, this comes in the Pro version, but also in that Pro version is a tool called Volumill. And the toolpath in Volumill is unlike no other. And you can, hopefully you guys can see that, or everyone can see that really well. It is an algorithm that is developed via technology called chip thinning. The idea is that the tool can take a much larger depth of cut and be able to run literally four times faster. So for high-speed machining, tool wear, machine wear, this is a high-end tool that you guys, or that everyone gets with the Pro version of SOLIDWORKS CAM. And I'm just going to do a simulation of this so you can see this tool in action. And I'll try and get it to where we can get it over here and slow it down a little bit as well. One thing I might point out is also in the simulation, you can stop by tool, by operation, by next tool, or at the next Z level. We'll set this to stop at operation, so we can just run through and play this up to the point where it gets into that tool path. This is a little added feature there that we're seeing. It's called rest roughing, where it literally looks at the diameter of the tool and it goes in and then just roughs the rest of it out. And this is our volume mill tool path. And I'll just speed this up a little bit. And you could notice it's in an oscillation mode. So it literally goes in and it keeps a constant chip load on that tool at all times. And this is where we can really raise your feeds and speeds and get that return on investment dialed in on your manufacturing. We'll just go ahead and run through that. Zoom this down a little bit so we can see some indexing here. Let's go ahead and we'll just take this thing and say run to the end. Now these tools can be sorted as well. So right now I'm doing everything on this one individual setup and then doing an index. However, we can also sort this by index, by tool, by operation. So if I want to run one tool all the way around before doing a tool change, all of that is quickly done just by using a right click and saying sort the tool path. And there's the volume mill and just a little quicker motion. And from there, we're just machining more parts. So we'll go ahead and just stop that and close. So basically what we did is we did a quick, simple part in SOLIDWORKS CAM standard, machined it, programmed it. We didn't show the fixturing or anything of that nature, but we're still able to get a good quality tool path out to the floor quickly. We then went into the turning environment where we showed a 2-axis turn part, which is included in SOLIDWORKS CAM Pro. We then programmed a part in a vise in the assembly environment, which is also included in SOLIDWORKS CAM Pro. And then we also talked about the volume mill toolpath, multiple vise models, multiple models in the assembly mode with multi-plane indexing, which would be 4 and 5-axis indexing capabilities. The only other thing that I would point out, or that I would like to at least mention, is for those people who are doing 3-axis simultaneous toolpath, there is some functionality in SOLIDWORKS CAM for 3-axis machining. It's fairly basic. You can do cusp height control, however, and you can actually machine a surface. When you create a surface for that part, it's a little different as far as how you would do that. We do cover that in our training classes. And I think that Chris may talk a little bit more about that. So, Jessica?
That was great, Rob. Thank you very much. And we'll pass it over to Chris to finish us off.
Some of the features that Rob just showed inside of SolidWorks CAM. Hopefully you'd agree that it's very easy to use. It has the same user interface as SolidWorks. It automatically recognizes the machinable features. Based on those machinable features, it looks at your technology database, which includes the tools in your tool crib and the machines that you have, and it applies the appropriate machining strategy based on how you've got it set up. That technology database is customizable. It's really easy to edit it. We can help you with that and make sure that you have professional machining strategies. Rob showed some really cool automatic stock definition. I really like the fact that you can use an STL file because it's seamlessly set up to utilize both additive manufacturing, 3D printed metal parts and do machining on those. All of the tool paths are associative. It's also very powerful. So while it's easy, and some of the first customers that we had with CamWorks were, Research in Motion in their test lab. They bought a Beckman CNC and they had no CNC machining expertise at all. Nobody knew how to write a line of G code, and we were able to get them up and running really quickly. Another customer, C2P, bought their first CNC machine, and I think that they're very professional at what they do, and we were able to get them up and running. But also some advanced customers like Anchor Danley. They have 7 plants and dozens of high-end CNC machines, and we were able to do an enterprise-level implementation with some very nice post-processors, and I know that they've appreciated the help of CAMs to really get the most out of their SolidWorks CAM and CamWorks implementations. Some of the features that you saw as well were high-speed machining, NC verification, the fact that all of the CNC toolpaths are embedded in the SolidWorks part and assembly files. And just think how this, while it's a very proven solution today, kids are going to be coming out of every college that uses SolidWorks, which is literally 100% of them, and they're going to know SolidWorks CAM, and the SolidWorks community of 2+ million users is just really going to make this CAM product become more and more the standard that we see. It's important to know that it's a very scalable platform, that you have access to CAM Standard and CAM Professional. Those applications are very professional, but if you ever want to take it to the next level, you have somewhere to go, and you can just simply upgrade into CamWorks if you need 4th and 5 simultaneous axes machining, or a live C axis, or nesting, or wire EDM. We have those options for you as well. So critical to any software, while it's easy to use, it should have a professional implementation. You're going to be spending, when you have a CNC machine, a lot of money setting it up, a lot of money acquiring it, and we want to make sure that we're professionally implementing it. So here's my 1, 2, 3s on implementing SolidWorks CAM. The initial tech DB, some customers do customize it right away, and we're more than happy to help you customize it. Some customers are budgeting sort of 10 hours at about a couple $100 an hour for us to help set it up. But really, for the average customer, you don't need to budget anything for this. That any kind of tech DB customization is so easy, it would be done during the training period. Yes, you're going to need post-processors. There's a series of post-processors that come for free with SolidWorks CAM. But again, considering the investment in capital and how good the post-processors that CAMS has, I would budget a little bit of money if you're thinking about implementing SolidWorks CAM for getting one of the professional quality post-processors that CAMS has. The type of questions that we're going to ask you are what kind of machine it is, what kind of controller, and is there anything non-standard that you're machining, and we can help you with that. You should probably take some training. We've got different options in terms of different training options. In class is always the best. We've got a training course coming up at the beginning of June at our Cambridge office. The CAM standard portion of that training is about 2.5 days, and the CAM professional is the full 4 days. We also do offer online training, live instructor online training, so that you can interact with the instructor and ask questions and, ask the instructor for help if you're doing any of the exercises. There's also a large library of recorded kind of tutorial-based training that's available if, you need to learn it on nights and weekends. So we've got your options covered. Those are the 1, 2, 3s of a SOLIDWORKS CAM implementation. Your next steps are simple. Whether you currently have CNC machines and a CAM system, or whether you have no in-house CNC at all, it's just to set up an appointment for a quick a rundown of your application to see if SOLIDWORKS CAM and CAMWorks is an appropriate solution. Feel free to email me at cwatkinson@cadmicro.com, or as always, call me anytime on my cell phone, 416-526-2042.
All right, thank you very much, Chris and Rob. That was a great presentation, and thank you very much, everyone, for joining us for another Webinar Wednesday. Please keep in mind that if you'd like to stay on top of our events, webinars, and all those sorts of things, you can feel free to follow us on social media, on LinkedIn, Facebook, Twitter, Instagram, or YouTube, or you can always check out our online calendar on our website to see what's coming up next. Thanks again, everyone, very much, and we hope you enjoy the rest of your Wednesday.